In this video, we want to learn about the simple statistics. When we say simple statistics, is that we want to know the basic things that we need to work with when we are dealing with the set of the data. Okay, so very often when we have a set of data, we might want to determine the location of the center of the distribution of our data. And the other thing is that we want to know the degree of the spread of these data sets. Based on these two interests, for the first part, which was we might want to determine the location of the center of the data, we would say the most common measure of central tendency, we call it mean, is the arithmetic mean. And so the first thing that we would say here for mean, we are gonna show it by y bar. And then it's like the mean that we would say. It's like that we would have the sigma yi over n, and then our I starts from the first data points to the end number of the data points. So this is the mean that we would have. It gives us like the center, right? The central tendency. The second thing that I said that we are looking for is the degree of the spread of the data set. So the most common measure of a spread for a sample that we use is the standard deviation. And so here, I would say a standard deviation of our sample, and then I will show it by S, a standard deviation of our sample. And then for this one, the way that we define it is that we would have for each of data points, we're going to see that what's the difference between our data points and our mean, right? Square it and then divide it by the n-1. So it's going to be something like this. Let's say I have, like we said, that we have n data points, right? So I would need to add them. I would need to have the sigma here. So it's going to be yi minus y bar power 2, let us square it, and then and the denominator we have n-1. So this is the standard deviation of the sample. And here, let's have I equal to 1 to n, because we have the n data points. These two definitions is that it's a mean and a standard deviation of sample. If it was population, this equation would be different. So the difference between population and sample, if I want to tell you quickly, is that, so let's say the whole Canada, it's like, we want to consider something in whole Canada. And then we would say, so everyone that they live in Canada, we would say that that's the population. When we want to get a sample, let's say we want to find out the body temperature of all the people in Canada. So it doesn't make sense, like in some specific situation. So it doesn't make sense to go up to even it's not possible that we would go to each houses and knock at the door and say, hey, what's your body temperature? So what would we do? We are going to get a sample. For that sample is like that, for example, we would say, okay, so let's have this amount of the people from this city, like from Toronto, these people from Calgary or from Vancouver, so from other Edmonton, different Waterloo, that we are now in it. So it's like we are going to find out the different, get the sample from different locations, right? So for that sample, this is going to be the equation that we would use, and you can see that it's like the difference, like deviation from the mean, the square of it divided by the n-1. So here, this denominator n-1, this one we refer it as a degree of freedom. So this one here, it's the degree of freedom. When we say degree of freedom, And a simple example for it, that if you want to see that what's the concept behind this degree of freedom, you can think about, let me give you an example. Think about this chair, like that I have here. If I ask you how many options that you have to sit, let's say you are standing here and I'm going to ask you that, how many options do you have that you're going to sit on the chair? So you would say that, okay, I have one option, which is this chair, right? So I can sit on it. I have one option, which is really good if I do like this. And then I can have another question, and I ask you that, okay, so look at this chair and you're standing here. How many choices do you have? This choice is degree of freedom when you think about the concept behind it. So my choice here is 0. I don't have any choices. There is one chair here, and if I wanted to sit on somewhere, I have to sit on it. So my choice is 0. So that's the degree of freedom. We would say that my freedom to choose among the chairs, it's 0 here, right? So this one is very similar. It is a similar way of thinking behind it. In fact, we would say that when the value of n minus 1, we use it because the deviation from the average must total be 0, right? And therefore, knowing n minus 1 values of the like yi minus y bar allows calculation of the nth value of this one. So that's the reason that we have this n minus 1 as a degree of freedom. So we also we said that this standard deviation, we use it to show the spread of the data, right? So there is another term as well, and we call it variance. And we also can use that variance as well. We can say that, okay, the spread can also be represented by the variance, which is the square of this standard deviation. So here I'm going to write down variance. It's going to be a square of this standard deviation. So that's the variance. There is one more term that we use it when we want to, for the quantifying the spread of data, and that's the coefficient of the variation. So I'm going to write it down here, coefficient of variation. And this coefficient of variation, sometimes they show it by CV, it's equal to the standard deviation divided by mean and multiplied by 100. So it's like that, my standard deviation divided by my y bar times 100. So this is another term that we are going to use it for when we are working with data. So now let's talk about the we talked about the standard deviation mean, right? Now let's say that, okay, I have a histogram and I want to see that how can I represent this data? Like, for example, we said that, okay, so we want to find out the central tendency. So let's show it in the graph. So when we are working with this data in statistics, we want to have the normal distribution. So in the normal, probably you have heard about that. We say that it's a bell-shaped curve. For the normal distribution, is like you're going to get your data points, then you're going to find out the frequency of these data points, right? And then you're going to have the histogram, like the same histogram that we draw with Excel, for example. So you have your histogram, the shape that you would have. If it's like the bell-shaped curve, we would say that we have a normal distribution. So here, I'm going to show it. So let's say I have my data points, right? And then I have the frequencies of the data points for different ranges. Let's say it's like this. Right? So and let's say another one here. So when I look at this one, for this data point, if I try to connect these histograms together, I can see that it's like a bell-shaped curve. In this situation, we would say that we have normal distribution curve. So this one here, it's normal distribution. So when we have normal distribution, so you can see that here is the central tendency, so that's the mean value that we were talking about, and about the standard deviation, which represents the spread of the data. So we can say that, for example, for the normal distribution, 68% of the measured variables, they will fall within one standard deviation. Or, for example, 95% of the measured variables, or like the data points that we have, they will fall within two standard deviation. And at the end, 99% of the measured variables, they will fall within the 3 standard deviation. So that's what we would say for this one. For the standard deviation and the mean of our sample that we have. So, as a last thing here, let me see if I can find another. Okay. So let's see, I have my data points like this, and let's say I had another distribution curve like this. Mean is the same, right? So if I ask you, and I'm gonna name this one from sample number 1, and this one comes from sample number 2. If I ask you which one, if you compare them, which one has a larger standard deviation, what would you say? Because when the standard deviation is larger, it means that the variance is, which represent from the error, right? That one is larger as well. So think about it for a moment. You can pause the video and come back and listen to the answer of it. That which one has a greater standard deviation. So when you see these two ones, it's obvious that the number 1, it's wider, like when you look at the spread of this wider. So we would say that it has a larger standard deviation. So here number 1 comparing to number 2 has a larger or greater standard deviation. So these are the simple statistics. These are the things that we need to know before going to learn about the least square method. If you're interested to know more about the stats, there are a set of videos on the channel which is talking about the and there's a playlist like a statistics, probability and statistics, which talks about the hypothesis testing, all of the regression models and different things that we would have. So you can go and look at it and watch those if you were interested. But for dealing with the data, just for finding out the curve fitting, different techniques of the curve fitting, if we know this amount of stats is enough for us. So let's go back to the curve fitting that we had in another video.